OpenAI CEO Sam Altman addressed an audience in Sydney on May 26, walking back his earlier predictions of widespread job losses from rapid AI deployment, acknowledging that real-world data contradicts his previous jobs apocalypse forecast. Instead of mass substitution, the pattern has been one of augmentation, where AI enhances human capability rather than replaces it entirely. Altman emphasized that human interaction remains essential in many professional roles, fundamentally limiting how comprehensively AI can substitute for workers. The shift reflects growing evidence from enterprise deployments showing companies use AI to amplify worker productivity while maintaining human oversight and creativity. This recalibration carries significant implications for how companies approach hiring and workforce planning as AI becomes more integrated into business operations. The acknowledgement signals an important inflection point in how the tech industry and broader economy view AI's labor market impact. A new World Economic Forum report released on May 27 indicates that artificial intelligence has become the dominant force shaping the global cybersecurity landscape in 2026, with 94% of organizations surveyed identifying AI as the top driver of cyber risk. Notably, 87% of respondents cite vulnerabilities in AI systems themselves as among the fastest-growing threats, indicating a dual vulnerability surface. The report highlights how AI significantly lowers barriers for cybercriminals, enabling automated, scalable fraud campaigns including phishing, malware generation, and sophisticated social engineering attacks. Particular concerns surround synthetic identity fraud and deepfake-based attacks, specifically targeting financial institutions, enterprises, and government entities. The European Central Bank has issued formal warnings to banks about AI-driven cyber risks, while policymakers are advancing concrete regulations around autonomous weapons systems. The convergence of these factors signals a critical inflection point, where organizations must simultaneously defend against AI-powered attacks and secure their own AI systems. Quantinuum, supported by industrial conglomerate Honeywell, filed for an initial public offering on May 27, 2026, in a move that could value the quantum computing company in the billions and represent one of the sector's most significant public debuts. The filing highlights the company's achievements in trapped ion quantum systems, error correction mechanisms, and hybrid quantum classical applications targeting drug discovery and materials science. This IPO timing reflects intensifying investor interest in quantum hardware companies as the technology transitions from research phase toward commercial deployment. The filing signals confidence in the maturity of fault-tolerant quantum system infrastructure, which investors believe could eventually transform AI optimization and cryptography. A successful public offering would validate quantum computing as a legitimate frontier technology asset class, potentially opening institutional capital flows currently restricted to private equity. Industry observers see the IPO as a catalyst that will accelerate ecosystem-wide investment in quantum AI hybrid systems and practical quantum applications. Micron Technology reached a historic $1.01 trillion market capitalization on May 26, 2026, with stock shares surging 19% in a single trading session, driven by insatiable artificial intelligence demand for memory chips. The company's valuation has grown roughly tenfold in a single year, from approximately $108 billion in May 2025, demonstrating the scale of the AI-driven memory shortage. UBS catalyzed the surge by raising its price target nearly threefold to $1.625 per share, citing evidence of structural changes in the memory market as data centers rapidly scale AI infrastructure. High bandwidth memory has become the critical constraint in AI infrastructure build-out, with Micron's entire 2026 production already committed to customers. The shortage has shifted pricing dynamics, allowing Micron and competitors like SK Hynix and Samsung to secure premium multi-year contracts with favorable terms. This milestone signals a fundamental market repricing, transforming memory chips from commodity components into premium strategic infrastructure assets essential to AI systems. American Airlines announced on May 26 that it will install SpaceX's Starlink satellite internet service on more than 500 of its narrow-body aircraft, with installations beginning in early 2027, deepening an industry-wide race among carriers to offer premium onboard connectivity. The rollout will cover American's Airbus fleet, including incoming A321neo and A321XLR deliveries, serving the airline's domestic and short-haul international routes. Starlink's low Earth orbit satellite network supports high-speed streaming, gaming, real-time video collaboration, and voice calls with minimal latency, a significant upgrade from traditional satellite internet systems. The deal builds on American's existing free Wi-Fi strategy, launched in partnership with AT&T using Viasat and Intelsat satellite technology, though Starlink represents a generational improvement in speed and reliability. For SpaceX, the American Airlines deal represents another major win for Starlink, heading into the company's anticipated initial public offering, where Starlink's connectivity business accounts for roughly 61% of SpaceX's total revenue. The broader trend signals that in-flight Wi-Fi has transformed from premium add-on service into a core competitive necessity as airlines battle for premium leisure and business travelers. Scientists at the University of Houston achieved a major breakthrough on May 27, shattering a 30-year-old superconductivity record by creating a material that achieves zero-resistance electricity conduction at 151 Kelvin, approximately minus 122 degrees Celsius, the highest temperature ever recorded for ambient pressure superconductivity. The achievement employed a novel pressure-quenching technique that first subjected the material to extreme pressure to enhance superconducting properties, then rapidly released that pressure while the material was cooled to critical temperature, effectively locking in enhanced superconducting behavior under normal pressure. The breakthrough moves researchers significantly closer to the long-sought holy grail of room temperature superconductivity, a development that could revolutionize power transmission, energy storage, medical imaging, and fusion energy research. The copper-based ceramic material developed by the Texas Center for Superconductivity team demonstrates that advances in materials science and engineering can progressively increase practical superconductivity toward accessible operating temperatures. While approximately 140 degrees Celsius remains between this achievement and room temperature, the success validates the pressure-quenching approach as a viable pathway for future progress. The implications extend across electrical grid efficiency, industrial computing, and advanced medical technologies currently constrained by cryogenic requirements. Researchers at UC Davis published a groundbreaking result on May 26, demonstrating an AI-powered spectrometer on a chip that compresses decades of laboratory spectroscopy technology into a device smaller than a grain of sand, enabling portable chemical analysis previously requiring bulky equipment. Rather than using traditional prisms or gratings to physically separate light into component wavelengths, the innovation employs just 16 silicon photodetectors, each engineered to respond differently to incoming light, combined with integrated neural networks that computationally reconstruct spectral information. The system achieves 8-nanometer spectral resolution across visible and near-infrared wavelengths, matching performance of traditional laboratory spectrometers despite its microscopic size. The AI component proves essential as the neural network learns patterns across thousands of reference examples, teaching itself to decode full spectral composition from partial sensor data, effectively solving a hard inverse problem. Practical applications span disease diagnosis, food quality inspection, pollution monitoring, and agricultural crop health assessment, all without requiring samples to be transported to centralized laboratories. The breakthrough exemplifies how AI addresses fundamental physics problems in materials, science, and medicine, representing a divergence from dominant conversational AI narratives toward applied problem-solving in hardware and sensing domains. OKX announced on May 26 the launch of Exchange OS, a major protocol upgrade to its X-layer blockchain that transforms the network into open, permissionless infrastructure, enabling developers and institutions to deploy custom cryptocurrency trading venues without rebuilding complex exchange systems from scratch. The upgrade fundamentally redesigns how trading infrastructure operates by moving core exchange functions, including order matching, margin management, liquidation, and settlement, directly to the protocol layer, eliminating the traditional requirement for each marketplace to implement these functions independently. Participants wishing to launch trading venues must stake OKX's native token, creating a financial filter while maintaining permissionless access for qualified participants. The system achieves impressive technical specifications, supporting up to 300,000 transactions per second throughput with zero gas fees for end users, while maintaining settlement finality. OKX plans a staged rollout, beginning with the simulated 2026 World Cup prediction market venue launching in June, intended to demonstrate the infrastructure in production before broader ecosystem opening planned for Q3 2026. The architecture incorporates enterprise-grade compliance capabilities, allowing each market operator to independently configure know-your-customer requirements, geographic restrictions, and surveillance tools, enabling regulated entities to participate within their required compliance frameworks. JP Morgan Chase announced on May 27 that it is rolling out artificial intelligence systems across its investment banking operations worldwide, deepening enterprise adoption of generative AI and automation tools within major financial institutions. Senior executives report that the technology is already demonstrating measurable value in research generation, document analysis, and transaction workflow acceleration, fundamentally changing how investment bankers approach client service delivery. The deployment extends JP Morgan's broader technology roadmap, building on recent quantum computing breakthroughs, where research teams implemented a quantum streaming algorithm achieving theoretical exponential space advantage for real-time processing of large datasets. The AI systems enable faster execution of complex portfolio optimization, risk modeling, and financial analysis that previously required extensive manual analyst effort, effectively amplifying team productivity and accelerating time to market for investment products. Beyond AI, JP Morgan's quantum initiatives demonstrate the firm's commitment to frontier technology infrastructure, positioning it at the forefront of financial technology advancement. The enterprise adoption patterns emerging across major financial institutions signal a transition from experimental pilots to production-scale deployment, with AI becoming foundational infrastructure supporting core banking operations rather than supplementary capability. Thank you for watching. Please do like and subscribe for more content and stay updated with the latest technology news.